Hello, Applied Physics students. Here is the teaching video for the Concept Development Practice, page 29.3. Again, here we're dealing with refraction. Okay, so this is what happens when light and different objects slow down or kind of change their direction, if you will, because they're slowing down when they change from one medium to another. Okay, so when they move from one type of substance into a different type of substance. So number one, okay, a pair of toy cart wheels that can spin independently are rolled obliquely from a smooth surface onto two plots of grass. A rectangular plot is shown on the left and a triangular plot is shown at the right. The ground is on a slight incline so that after slowing down in the grass, the wheels speed up again when emerging on the smooth surface. Finish each sketch and show some positions of the wheels inside the plots and on the other side. Clearly indicate their paths and directions of travel. Okay, so we can kind of think about this just like from a practical, right? So this is like concrete around this grass. So again, what's going to happen to these tires, right? They're out here, they're both rolling at, both tires are moving at the same speed. However, right, this tire here is going to hit this grass before the other tire does, right? At this point, this other tire is still not on the grass. So this tire is going to slow down. If this tire slows down, which way is that going to kind of force this to move, right? This tire is still moving faster than this one. So that's going to cause, okay, this path to be bent. And it's going to bend this way, right? Because this tire on this side is slowing it down, okay? So maybe it bends about like this. And then it's going to continue, right? Once that other tire is back on, and both tires now, right, are back on the grass, now the tires are going to move at the same speed. So now coming over here, right, as we approach this way, right, this tire is going to come off and start to go faster. So if this tire is going faster on the bottom, if we will, okay, then it's going to cause, right, it's going to still bend towards the slower tire, which is this one here. So this is going to bend back, okay, this way. So when our wheels come off, they're going to bend this way. And so that's sort of what our path would look like. Well, in this triangular one, this is going to be even more pronounced, right? Because this tire is going to reach this much sooner and be on here on this grass for a longer period of time. So instead of just kind of a slight turn, we're going to have a pretty significant turn. In fact, this would kind of end up turning almost pretty much straight here. And again, once the tires are both on the grass, they're going to move at the same speed. Now, again, same thing here, right? The tire that hits first, okay, is going to be this tire. So again, this tire is going to be slower down here. So we're going to bend that way, okay? And so we're going to, here we are, and we're bending, and we're going to kind of bend pretty significantly again. So we may come off like this, okay? So here's our tires, right? And here's our tires. Okay, so that's sort of, now, this same idea, light works the same way. A light ray, if it was entering, right, this side of the light ray is going to slow down more, and it's going to bend that light this way. Then when the light is emerging from like maybe a glass window, right, it is going to, this side is going to speed up more quickly. And so again, it's going to bend back towards the slower side. So light behaves exactly the same way as these tires do as they roll across the grass. So we have red, green, and blue rays of light are incident or shine upon a glass prism is shown. The average speed of red light in the glass is less than in air, so the red ray is refracted. Okay, so again, it slows down here, and so it bends this way. Okay. When it emerges into the air, it regains its original speed and travels in the direction shown. So again, if I kind of think about like tires, right? This tire is going to kind of get out faster and kind of cause, right, some bending. So this is going to bend, okay? This one's going to be going faster than this one, and so this is going to cause it again that this light would be coming more straight, and it kind of bends it this way. Okay. Green light takes longer to get through the glass. Because of its slower speed, it is refracted as shown. So because it's a little bit slower, it's kind of a bigger angle here, right, both times. Blue light travels even slower in glass. Complete the diagram by estimating the path of the blue light. So we're going to have, because it's even slower, it's going to bend even more. Okay, so it's going to be a more significant bend. Okay, and it's going to be a more significant bend even as it comes out. So that might be what our blue light would look like. Because it's moving even slower here, and so it's going to cause like those wheels to be spinning a lot faster on the fast side and a lot more slowly on the slow side, and bending it more significantly. So the sketch below shows that due to refraction, the man sees the fish closer to the surface than it actually is. So that's what this picture is down here, right? Because there is this angle bends, right? Because it slows down and it bends down. The actual fish is here, but again, idea is there's sort of this virtual image of the fish a little bit higher than what it really is. So draw a ray beginning at the fish's eye to show the line of sight of the fish when it looks upward at 50 degrees to the normal at the water surface. Draw the direction of the ray until it meets the surface of the water and continues in the air. Right? So this actual fish, right, here's our ray, and again, they kind of already put it on here for us, but here it's going to be reflected as well as passing through. And so it's going to look like this. Okay? Most of the light is going to do that because it's going to be, the surface of this water is going to be acting like a mirror for the fish. At the 50-degree angle, does the fish see the man, or does it see the reflected view of the starfish at the bottom of the pond? It's going to see the starfish. And again, that's because the surface of the water acts like a mirror. For the fish. To see the man, should the fish look higher or lower than the 50 degree? Okay. And it would have to, right, to be able to have, right, even if this continued, right? And again, it is going to speed up as it moves. So it would be kind of like this. The fish is definitely not going to see the man. To be able to see the man, right, we would have to it would be bent. This side is going to move slower, so it's going to be bent more like this. So it's coming here at 50 and it gets bent. But so you might see like the arrow that the guy has. Okay. he would have to be looking, okay, kind of at a little bit of a different angle, maybe about like this, okay, to be able to see that man. So it would be a different angle. The rest of that's more than what we are been talking about. So we're not gonna look at this, but he would have to look higher, okay, than that angle.